All right, everyone. Today we are going to continue our talk about recursion in exponential growth and decay. So today's scenario, which we're going to be looking at multiple problems in regards to, is that Derek is trying to save money for the down payment on a used car. His parents have said that, in an effort to help him put aside money, they will pay him 10% interest on the money Derek accumulates each month. At the moment, he saved $200. So I do need you to write this down. You're going to be writing the scenario down and every question down in addition to the work we take to solve them. So big thing here, let me see this. Right, helping him 10% interest each month, and we've already saved $200, which is great. All right, so suppose Derek does not add any money to the savings, right? So that means we're just relying on that interest his parents are putting in. Write a recursive rule, okay? Recursive rule and an explicit function rule that models the money Derek will accumulate with only the interest. Now remember the difference between recursive and explicit, right? Recursive is going based off the previous term. Explicit will return any term. Okay, so let's do it with recursive. So we're going to let n equal the number of months and d equals dollar saved. Okay, so our recursive, let's say dollar saved, is going to be equal to the previous term times 0.1, where our initial case, d sub 0, is $200. The explicit rule, remember that's just going to be like y equals a times b to the x, where b is the rate and a is our initial amount or number. So we're going to have d is going to be equal to 200 times, and actually I shouldn't say 0.1, right? Because to get the additional amount, right? Because if I do this, right, if I do this, I'm only going to figure out the amount I need to add. I want to figure out the total amount. So I want to put 100%, right, which is 1, and 0.1. So that's 100, essentially 1.1 is equal to 110%, because I want 100% of the original amount, and I want to add that 10%. I want to add that 10% from the parents to the end. So how long will it take Derek to save at least $2,000 for the down payment if the only additions to his savings account are his parents' interest payments? Okay, so I'm definitely going to be use the explicit here because it returns any term, right? If I was doing recursive, I would have to go each one by one. So let's just start with 1. Let's say d equals 200 times 1.1 to, let's say, 10. I'll get my calculator. Yeah, this might be hard. Let's go to Desmos. Okay, so we're at $518 at 10. Okay, so now let's try 20 months because that's kind of small. We need more. So d equals 200 times 1.1, 20, right? So here's after 10 months. after 20 months. Let's see how much that will be. So let's just replace that with a 2. We're closer, 1345. Okay, so then let's try after 30. Ooh, 3,489.88. So a little too much. So let's scale it back. Let's try 24 months. Ooh, we're so close, and let's just put that 25. So 25 months he would have at least. So after 25 months, he would have at least $2,000. Specifically, he would have 2,166.94. In an effort to speed up the time needed to save $2,000, Derek decides to take on some jobs in his community. Suppose he commits to adding $50 per month to his savings. Start with the initial deposit from his parents. Show the amount of money Derek will have over several months. Okay, so let's do it. We're going to just kind of make a table here. We'll have a month, we'll have the equation, and then we'll have the total. Okay, so month 0, he had $200. Okay, so then month 1, we would have 200, right, times 1.1 plus 50. Okay, we're at 270. After 2 months, okay, so 2 ways you could do this, right? I could say either 270 times 1.1 plus 50, or instead of writing 270, you could write 200 times 1.1 plus 50 times 1.1 plus 50. That's the long-winded version. And let's see. So essentially, that's going to give us, I'm just going to replace this with 270, 347. We're getting nice even numbers here. So 3 months. Okay, it's going to be 347 times. Let me erase that. 431. I should write the units here. We're talking about dollars. 431.7. Let's do 2 more. So 431.7, 70 cents times 1.1. I'm going to put parentheses here because that's what you do first. Plus 50. 431.7. 524.87. And last one. 627.36. Nice. So we got a good amount here. Make a scatter plot of the data you've generated in the table and compare the scatter plot to the function rule, aka this is just the explicit rule for question 1. How does $50 per month to Derek's savings change the way in which his money grows? So what I want you all to do is I want you guys to go to Desmos.com. I want you to go to your graphing calculator. You're going to input both the explicit formula, okay, the explicit formula that we found in question 1, and then you're also going to put explicit. Doesn't want to let me do it. Oh well. And then you're also going to insert, put a table, and then those 5 values that we had. So month 0, month 1, month 2, okay? This is what you should get, okay? So how does the $50 per month change the way in which the money grows? Well, we're definitely going to reach our goal a lot faster. We're definitely going to reach our goal much faster with the additional 50. How long will it take Derek to save $2,000 for the down payment if he continues to add $50 every month? Well, there's no really simple way to do this, right? Like, we can't, it would be really hard. Yeah, there's no really way to do it with the explicit way. We have to just continue to do it the recursive way. So, let's see, we're left off at 5. I want you all to go ahead and try and tell me how many months. How many months? So we left off at 5. So you got to figure out 6, 7, 8, 9, 10, and keep going until you get at least $2,000. Okay, probably took you a while, but it is 14 months. 14 months. How would you write a recursive routine to model this situation? The explicit rule, I'm going to tell you right now, it's going to be really hard. But let's go ahead and just look at the recursive. So it's going to be the n minus 1, so the previous term, times 1.1 plus 50. Simple enough. The issue is we couldn't do the explicit rule. Like, we would just have to keep writing it out the way we had it before. Like, yeah, it's just not possible. Because that plus 50. It would look like this. It would be, because the issue is that plus 50 makes us depend on the previous term. Suppose Derek changes the amount of money he adds to saving each month to $100. How does this affect the time it takes to save $2,000? How much does he have to add to his savings each month to have enough money for the down payment on his car in 6 months? Okay, explain your responses. Okay, so let's first look at $100. Okay, so if we have month 1, or let's just do month, equation, and then total, right? So month is 0, we have $200. Month 1, right, it's going to be just like before, 200 times 1.1, then plus 100 this time. So let's go here. That's 320. Okay, after month 2, it'll be 320 times 1.1 plus 100. $452. 3, 4, 5, 6. I'm just going to keep doing it here. So 452, 597.2. 756. 932. 1125. So pretty close. All right, so I want you to experiment to figure out how much he has to add to savings each month so that when we get to month 6, we end up at $2,000. Okay, drum roll, please. If you got, we need to add $200 a month to get to $2,000 in 6 months. You're correct. Okay, until next time, we'll be diving into more things. So hopefully we are making sense of everything we have done so far.